Good morning, Math 1. Welcome to our last section of Chapter 3, where we are going to look at maybe some more efficient ways to solve equations. I will try to skip through this pretty fast. I will only do partial examples, you'll see, and we'll get after it. So, Chapter 3, Section 11. Bam, here we go. We are solving equations that have fractions and understand equations to be equivalent, I guess. So, solving equations that include decimals or fractions can sometimes be tricky. I don't think decimals are that tricky, but whatever. Let's look at some ways to rewrite the equation that have decimals or fractions in it so that we clear out the decimals or fractions. So first we want to talk about what are equivalent equations. And it says here that two equations are equivalent if all of their solutions are the same. Well, there are several ways to change one equation into a different equivalent equation. You guys already know this. If I have 2x plus 3 equals, I don't know, how about 17? One way to change this equation into an equivalent equation is to subtract 3 from both sides. That gives me 2x equals 14. These equations are equivalent equations because all their answers are the same. Pretty much as long as you do the same thing on both sides of the equal sign, as long as you change the equation by doing the same thing on both sides of the equal sign, you have yourself an equivalent equation. So let's look at some things we can do. All right, one thing we want to be able to do is clear decimals or very large numbers. I'm going to do an example of each here in a second. Let me explain though. You guys probably know that multiplying by 10 moves the decimal one spot. Like if I had 74.32 and I multiplied that times 10, that would equal 70. I blew that one already, didn't I? How about 743.2? I have moved the decimal one spot. Multiplying by 10 moves the decimal one spot. How about multiplying by 100? Multiplying by 100, or 10 squared, because there's two zeros, moves the decimal two spots. So if I had 74.32 times 100, that would equal 7,432. And the decimal has moved all the way to the end. This is the basis for clearing decimals out of a problem. You can clear the decimals by multiplying both sides of the equation by a power of 10. That is large enough to make every number into a whole number. All right? It's pretty, maybe you've seen this before. Pretty easy though, right? So if I have this example here, the first thing I look at is I've got all these decimals, and how far do I need to move the decimal to make all of them into whole numbers? Like, I want to move the decimal to the end of each number. So this one would have to move one spot, one spot, one spot, one spot, no spots, but this one, 2 spots. So I'm going to have to move the decimal 2 spots so that every number becomes a whole number. And if I want to multiply, or if I want to move it 2 spots, I'm going to multiply by 100. If I only wanted to move it 1 spot, I'd multiply by 10. If I wanted to move it 3 spots, I'd multiply by a 1 with 3 zeros, 1,000. And you don't need a calculator for this. You're just moving the decimal. So this would be move the decimal 2 spots. And it would be 750, right? It'd go past the 5, and then you'd have to throw a 0 on there. 2 spots here would be 480. 2 spots here would be, I don't need the 0, it would be 30. 2 spots here would be 250. 2 spots here would be 1,002. And finally, 10 times 100, 2 spots here would be 1,000. And I didn't write small enough. It's sad. And now I have cleared the decimals. And maybe I would simplify it next by combining my like terms. I don't think we're going to finish solving it. Over here I could combine. I could have done this in the first place, but it's easier now. That's negative 750x squared plus 1,000. And I have cleared the decimals. I could basically do it in my head now and not need a calculator. Hey, look, do you remember this? This problem has both a x squared term and it's got an x term. So fortunately, like all the problems for us, the x squared term is going to cancel itself out because it's the same on both sides. So really this problem, I just add 30 and divide by 480 and I'm done, right? All right, so that's an example of clearing the decimals. Maybe that makes you a more efficient equation solver. You don't have to do that though, but it's nice to know how. All right, the second one here is I've got large numbers in a problem. These aren't even that large, but I'm going to use it to demonstrate what I'm doing. Instead of multiplying by something, in this one I'm going to divide by something to get rid of all the large numbers. I notice that these numbers are all in the thousands, so I can get rid of them if I divide everything by 1,000. Now the tricky part is right here. This is all one term. It's two things multiplied together, which makes it one term. So when I divide by 1,000, here that would be 2 times x minus 24 plus 5 equals 18. And there I have simplified the problem by getting rid of the large numbers. Now, I'm not sure thousands are that important to get rid of, but maybe if they were millions or billions, it might be handy. That is one skill to get rid of very large numbers. Divide by something. In this case, I divided by 1,000, and I don't think I need to finish solving that. Last thing, and this ought to be a review. I hope you did this in Math 8 last year. But if not, here we go. We're going to add to it a little bit, though. Clearing fractions out of a problem. We like to call this the fraction busters. So one method of clearing fractions is to multiply both sides by the common denominator. Make sure when you do this, you multiply each term on both sides, including those terms that do not have fractions, right? They still get multiplied. So your job here is to find the common denominator and multiply the entire equation by the common denominator. Now the last example or two, a little bit tricky, so stay with me. I'm not going to take that long on these. So the first one has a common denominator. Let's write that over here. Common denominator equals, let's see, what do 6 and 8 both go into? Well, I could multiply them together and use 48, but I happen to know a smaller number, 24. But you know what? Multiplying them together will always get me a common denominator. 24 I'm going to go with though, right? So I'm going to take this entire equation and multiply it by 24. You know, one thing I teach my Math 8 people to do that makes this pretty easy is, and you can do it really quickly in your head instead of getting a calculator out. I can do it quicker in my head than on a calculator, is when you multiply this whole number, the 24, times each fraction, divide by the bottom, then take the result and multiply it by the top. That's how you do it quickly. Divide by the bottom, then multiply by the top. So like in this first one, I do 24 divided by 6, that's 4. 4 times x is 4x. Then I go to 24 divided by 8, that's 3, times 5 is 15. And 24 times 4 is 96. I have cleared the fractions. I'm not going to finish solving it. I know you guys all know how to solve it, right? Add 15, divide by 4. The skill we're working on here is just, let's clear the fractions and make sure you know how to do that. In the second example, the common denominator. I hope you all know what this one is. That's a pretty easy one. What do 2 and 3 both go into? How about 6? So I'm going to multiply everything by 6. Remember, the quick way. Divide by the bottom, then multiply by the top. It works every time and it's quick. So 6 divided by 3 is 2. 2 times 5 is 10. X. Then 6 divided by 2 is 3. 3 times 15 is 45. And then 6 divided by 2 is 3. 3 times 5 is 15. There is our new, simpler equation where we have cleared the fractions. Very good. On to letter C. All right, so this I'm not sure you've seen. I have a variable in the denominator. So with a variable in the denominator, I need to include that in my common denominator. And what I said before is still true. One way to get a common denominator is just to multiply the denominators together. So in this one, I could just multiply the two denominators together, and that would make my common denominator 8x. And I'm going to multiply each term by 8x. So that might look like this. So I want to take this one a little bit slower. When I multiply 8x times 5 over x, that would look like this. Now what you ought to see here first is, well, I guess maybe we ought to make the 8x into a fraction so they're both fractions by putting it over 1. And now before I multiply, look what I can cancel out. I have an x on top and an x on the bottom. They cancel out. Or over here, the x on top and the x on the bottom, they cancel out. And then you'd multiply by the top that's left over. 8 times 5 is 40. So this turns out to be 40 minus. Then I have 8x times 2. We all get that, right? That's 16x. And then I have 8x times 11 over 8. So this time it's the 8 that cancels out. You do 8 divided by 8 and you get 1 in both cases. And so, but you can't forget that x there. So now you have 1x times 11, which is 11x. All right, I hope you get that. I'm going to do it one more time here in a second, but I have now cleared the fractions and I got the variable out of the denominator, which is always nice. Last example and we're done. All right, so here I could multiply the denominators together and use 4x. And 4x would be a great common denominator, but there's a smaller one, right? I don't need the 4 because I could just use 2. Both the denominators have a 2, and 2 certainly goes into 2. I don't have to have it go into 4. So I'm going to use the smaller one. I'm going to use 2x. And I'm going to multiply everything by, I see an issue here. Did you catch that issue? We'll do it next, just for fun. So 2x. So 2x, when I multiply by this, the 2x divided by the 2x is 1. And 1 times 7 is 7. If you want to see it over here, it might look like this. Now I have a 2x on top and a 2x on the bottom, so they cancel out. And I'm left with 7. Plus 2x times 3 over 2. This time, I divide the 2 by the 2, and I get 1. So up here, I have 1x, and 1x times 3 is 3x. And finally, I have 2x times 3.25. Well, 2 times 3.25 is 6.5. This would be 6.5x. Now, it would have been nice if I'd cleared out that decimal as well. Sadly, I did not, but I could still clear it if I wanted to. I could now move the decimal 1 point, 1 spot, by multiplying everything by 10. Or, well, originally I could have done something else, but I'm going to go ahead and multiply everything by 10. I'm not sure I would actually do this, but the directions said to clear the decimals and clear the fractions, and now I've done it. And I could finish solving it, and I'm sure you could all finish solving that. The lesson today was learn how to clear fractions, learn how to clear decimals, learn how to clear very large numbers, and then just finish solving the equation. All right? I will see you guys tomorrow.